All right, here we are in Part B. Same problem, 2009 BC6 Part B. We're being asked in Part B to write a Taylor series, or use the Taylor series here found in Part A. This is Part A right here. Okay. To write a Taylor series, for the first four non-zero terms, of f. And so f was e to the x minus 1 squared minus 1 over x minus 1 squared. So what we're going to do is we're going to take this existing series and we're going to subtract 1 from it. So if we subtract 1 from it, that takes care of that guy right there. So no longer do we have a 1 in our series. Okay, the first term then would be this guy right here. That's the first term. Okay, well, we're going to divide every single term by x minus 1 squared. So if we divide this first term by x minus 1 squared, we're actually going to get a 1 there. And then we take this one here and we divide by x minus 1 squared. Every single term gets divided by x minus 1 squared. And x minus 1 squared also is what the nth term gets divided by. Okay, so let's see how that all pans out. Let's use a different color here. So this guy goes to 0, and then we have this guy here goes to 1. Okay, and then this guy here, x minus 1 to the 4th over x minus 1 squared. Well, that's x minus 1 to the 4 minus 2. So that's x minus 1 to the 4 minus 2 is 2 over the 2 factorial. Okay, plus x minus 1 to the 6 minus 2 is 4 over 3 factorial. Okay, and we need one more term before we get to that nth term. So if we think about what this would have been up here, our next term, let's see, that's n equals 0, 1, 2, and 3. Well, what would the 4 be? So maybe down in this little area here, if n were to equal 4 in the first series, then we would have x minus 1. You know what? I'll do that in yellow, because that's the color it was in up there. We'd have x minus 1, and we'd raise that to the 2 times 4. I'm just using the nth term now. 2 times 4 would be 8. Okay, and then we divide that by 4 factorial. Okay, well now then where's that color? Our fourth term then in our current series would be x minus 1 to the 8 minus 2, which would be 6. We could have used the pattern as well, and then we would still have that over 4 factorial. Okay, plus dot dot dot, so we want to make sure we get our nth term as well. And our nth term we divided by x minus 1 squared, so we have x minus 1, let's see here, we have plus x minus 1 to the 2n minus 2. 2n minus 2 over n factorial. Okay, and so how does that work out? 2n minus 2, does that work out with 0? What would we have done there? Okay, 2n minus 2. So if we did that, how would that change things? 2n, and then we'd have an x minus 1 here to the second power. That cancels that out. So yeah, I guess there's really nothing much else we can do with that. X minus 1 to the 2n over n factorial. So what are we doing here? How do we find that nth term? X was 6, 4 factorial. How do we get x minus 1 to the 2n up there? And then, how do we get that? Okay, I stopped for a second because I'm like, wait a second, I actually looked up at the answer and it didn't have what I was going to put, but I was just going to put 2n minus 2 up here, and I'm going to leave it like that. But then I'm looking back, okay, does that give me what I need. And with the multiplying and dividing and everything, you have to check back at your first term. Well, if I put an n equals 0 in for n, then what I'm going to get is, so if n equals 0, then I'm not going to get my first term. Well, let's try n equals 1. So if I start n at 1, then I'm good here. 2 times 1 minus 2 is 0. That checks out for the first term. And then 2 times 2 minus 2. And so when n is 2, then we get the second term when n is 3, when n is 4, when n is n. So in other words, sometimes that's just going to happen. Sorry for the pause there. I didn't want to make a mistake and give you a bad solution. But yeah, I mean, that's what happens. You always have to check that nth term. And this particular, for this nth term, we're starting this series at n equals 1 instead of starting it at n equals 0. And that's what I always tell you. If you're not going to start the series at n equals 0, then you have to state what you're starting it at. So there you go. And hopefully that helps you with part B, and then we'll move on to part C for the next one.